Hello, my name is Amanda Jones, and in this video I'm going to show you some multiplication in base 5. Now we do this to kind of get in the mind of our student and how they feel when they're first encountering multiplication in our algorithm and our manipulatives, and you should spend a lot of time with manipulatives before moving to an algorithm. And so we're getting kind of in their mind because base 5 can be frustrating and it can be challenging, and we need to feel that for our students. It puts us in that mindset a little bit more since we don't understand base 5 as well, because we've just learned it. And so I'm going to show you this, and remembering with base 5 we regroup at 5, so everything's going to feel very similar to how we do multiplication, except we are going to regroup at 5. So thinking about how many 5s in each value and how many 1s. Okay, so we'll start with 321 base 5 times 24 base 5. Well, I'm going to use a standard algorithm. I think it'd be great practice for you to kind of go back and maybe try it with a lattice or try it in partial sums and see the connection. And I think that's great practice for understanding multiplication even better. But today I'm going to show it just in our standard. So setting it up, stacked. I like the smaller digit number on the bottom. So if it was here, I would reverse it, okay, because multiplication is commutative. All right, we'll start just like we do in the standard. 4 times 1. 4 times 2 is 8. So how many 5s are in 8? Well, there's 1 5 in 8, and then 3 1s left over. It's division, remember, when you're converting to base 5. 4 times 3 is 12, plus 1 is 13. There are 2 5s and 13, because 5 plus 5 is 10, okay? And then 3 left over. So over here in this place value, and then the 3 in that hundreds, okay, which is actually a 25 when we're in base 5. Okay, moving to the next one. 2 times 1 is 2, and remember this is a 20, a 20 times a 1. So it is going to go here with a 0 in this place value. 2 times 2 is 4. And 2 times 3 is 6. That's one. That one, I probably should have crossed it out. It's from this. 2 times 3 is 6, which is 1 5 and 1 1. And now we do addition, making sure that you are doing base 5 addition. So once again, regrouping at 5 and never writing a number that's greater than 4 in a place value, in a single place value. 4 plus 0, 3 plus 2 is 5. So carry that 1 and 0 5s. 0 1, excuse me. 3 plus 1 plus 4, so we have 8. So 1 5 and 3 1s. And then we have 4 and 1. 1 4 3 0 4 base 5. And then let's do another example. 2 3 4 times 4 3. And base 5. Okay, set it up. Just an additional example. Some larger numbers, so maybe more regrouping with our multiplication. 3 times 4 is 12, so we have 2 5s, 2 1s. 3 times 3 is 9, plus the 2 that we carried, so we have 11, which is 2 5s and 1 1. 3 times 2 is 6, plus 2 is 8. There we go. I'm going to cross these out like I was saying earlier. Or you can switch to a different color, make math a little bit more colorful. 4 times 4 is 16, which is 3 5s and 1 1. And this is in the second place value because it's in a second place value here. So we need a 0 in the 1 spot. 4 times 3 is 12, plus 3 is 15. So that's 3 5s and 0 1s. And then 4 times 2 is 8, plus 3 is 11, which is 2 5s and 1 1s. And then we do our addition, making sure you are in base 5 addition. So we would regroup at 5 if we needed to. There you have it. 2, 3, 2, 2, 3, 2, 2, base 5 is the answer here. All right, thank you for watching. Bye.